My name is Anne Egan. I'm a consulting engineer with R.J. Burnside and Associates Limited. This presentation describes a communal sewage system case study. In my presentation today, I'll give an overview of the site and the situation. I'll talk a bit about the Ministry of Environment requirements, some of the challenges and opportunities we faced with this project, the options that we considered, and ultimately what we did in terms of implementing a solution. This project was for an existing residential community of about 100 units. It's privately owned. It's year-round, so people live there full-time. This is their primary residence. It's within an established community, and it has water supply from that municipality. The on-site sewage servicing is a mix of individual, some shared, and a large communal sewage system. In 2012, the Ministry of the Environment did an inspection on this property, and they directed the owners to complete an inventory of all the systems on the property, assess each system in terms of its capacity and its functional condition, identify any deficiencies and make recommendations to address these deficiencies, to apply for an environmental compliance approval for the entire property and all the sewage works, and to establish a municipal responsibility agreement, MRA, with the municipality. There were definitely some challenges with what the ministry had tasked the owners to do. There were more than 60 sewage systems on this property with very few records. We had one certificate of approval for the communal system, but the other individual and shared systems did not have any available records of what was in the ground. We didn't know exactly what was there or where things were located, and there had been some change of ownership of the property, and that's part of the reason that there were not good records. So the current owners knew some locations of things, but in order to really inventory exactly what was there, there would be a significant cost to do that for that many systems. And there was also a concern that some of the older systems, which were most of them, may not meet current requirements in terms of the sizing. So we did develop a field program to try to gather some more information about what was in the ground, and we started that with a GPR, ground penetrating radar survey. But we did have kind of limited success with that method for a number of reasons. There were a lot of other obstacles in the way of doing a successful GPR survey. So there's a lot of other buried utilities, a lot of fences and decks and other things constructed over time that interfered with where we needed to look for these systems. And some of them were buried a little deeper than normal, so they were sort of out of range of what we would be able to successfully determine with that equipment. So the next stage of our field program was to do an intrusive inspection, and we did that by selecting 14 systems as representative of the different time periods that the property was built out. So we selected a handful of systems in each part of the property, and we conducted field investigations to look at both documenting what was in the ground and also just documenting the condition that that infrastructure was currently in. So the results of our field work and our inventory was that we really do have a little bit of everything on the site. Mostly they were in-ground conventional systems. The soils were quite conducive to in-ground leaching beds. So some of the houses had their own individual septic tank and leaching bed. Some of them were shared, so there might be 2 houses with a shared tank and bed. In some cases, they each had their own tank, but then they shared the leaching bed. So it was a real mix of things, and there was one communal system for about 27 units. So most of the systems, other than the communal one, were estimated to be more than about 35 years old. We weren't sure the exact age of these, but they were definitely had been in the ground for a long time. The tanks that we investigated were concrete, and most of them were a typical 800-gallon residential size septic tank. We did find them in a range of different conditions. Some of them were in quite good condition with minimal deterioration of the concrete. Others were significantly more deteriorated. Either the tank itself or the baffles were not in good shape. And you can see in the photo in the top right that when we tried to open the hatch on this particular tank, the concrete was so deteriorated that a piece of the lid actually broke apart. We also found that some of the tanks were found located partially or fully under parts of the dwellings due to additions that had occurred over the years. People had constructed additions to their units without really considering that it would be over top of the septic tank. We found a few different types of leaching beds on the property. A lot of them were clay tile trench beds, which we're assuming were original to when the units were constructed. Some of the units had more of an area bed style of system that was a stone layer with the piping network throughout it as opposed to trenches. All of the beds were in ground and the soils are quite sandy, so that they had just been installed in ground in the native soils. And we also found a couple of leaching pits in the oldest parts of the property, so there was a little bit of a mix of different kinds of systems, but overall, with the exception of the leaching pits, the beds were generally found to be in relatively good functional condition, just particularly considering the age of some of these systems. They were actually not in terrible shape at all. They looked like they were reasonably good, very limited biomat and sludge buildup in the trenches that we did look at. And now again, we were only looking at a sampling of systems and kind of extrapolating those results across the rest of the property. So it's always possible that there were other systems on the property that maybe weren't in the same condition, but the ones that we did look at were in relatively good shape for their age. So certainly there were some challenges associated with this, but there were also some good opportunities here. We definitely had the advantage of good sandy soils working in our favor, and that keeps the size of the sewage systems relatively small. And most of the existing systems were generally functional. They were working fairly well. The owner had a good maintenance program where they had made sure that each tank was pumped out on a rotational basis or more often if that was needed. Although we couldn't really speak to the previous maintenance history under previous property owners, we knew that the current owner was conscious of ongoing maintenance of all the systems. And we also knew from the ongoing groundwater and surface water monitoring that had been required by the ministry over a number of years, we had data that showed there was no discernible impact on groundwater or surface water quality as a result of the sewage systems on the property. So those were all good things working in our favor. And some of the challenges we had were mostly related to site constraints. So it was a fairly large site with the units spread out in different areas of the site, so different clusters of units. There's a couple of large ponds in the center of the site. And we also have a shallow groundwater table that becomes a real challenge for any in-ground leaching beds. And also just during construction work, we have to manage the water table. And most of the site is within a regulated area and subject to Conservation Authority requirements. So although we had a sizable property overall, by the time we look at all the different constraints and things we would have to accommodate, we really aren't left with a lot of usable or a large enough single space that would accommodate one communal system. So we did have to look at a couple of different options as part of our work. In terms of the approvals that were required, since the property generates more than 10,000 liters per day of sewage, it does require an environmental compliance approval from the Ministry of the Environment, Conservation and Parks. The existing approval was for one communal system on the site, but we needed to amend that to include all of the systems on the property. And because the units are year-round permanent residences, a municipal responsibility agreement, or MRA, was something that the ministry required for this site. So this agreement would be between the owner and the municipality, and it would set out the requirements and the financial reserves for the municipality to assume operation of the sewage systems in the event that the owner could not provide the essential service to the residents on the site. So we approached the municipality and we tried to initiate these discussions, and we gave them some examples of similar MRAs. We really didn't get very far with this. The municipality did not welcome the idea of an MRA, and we really were not able to convince them that we needed to establish this agreement. So unfortunately, that's not uncommon for municipalities to refuse to sign an MRA just based on the perceived risk associated with this type of agreement. But since these were existing dwellings, we needed some alternative to the MRA to provide, to achieve the same objective. So we ended up implementing financial assurance as a condition of the ECA. The ministry put on the requirement for financial assurance. So since the municipality refused to enter the MRA, the owner puts up some financing with the province to achieve the same objective. So if in the future there is a problem that the essential services can't be provided, then there is some reserve money there to provide operation of the system. And also, just because this site was regulated by the Conservation Authority, we did have to get some additional permits from them for works in the regulated area. So as part of obtaining the environmental compliance approval for the sewage works, we did consider several sewage servicing options for the site. We looked at whether we could maintain or upgrade or replace the existing systems at each unit or pair of units. So in order to do that, we would need to demonstrate to the ministry that all systems are adequately sized and that they're functional, and that any deficiencies would be addressed as part of any upgrades. And that would require some additional field work on systems that hadn't been investigated during our initial inventory. So there would be some advantages to this option. So we would potentially be able to reuse or retrofit some of the existing components. And it would also eliminate the need for installation of a collection and conveyance system to move the wastewater to one centralized location on the property. So because the units were kind of spread out in different areas, there would be a need to install some collection system to make this work. But there was also limited space in the yards around the homes, which meant that even with the good sandy soils on this site, maintaining individual units would require treatment units and reduced leaching beds in order to fit them in the space that we had and meet today's standards. So this was going to result in many systems for the owner to operate and maintain. So that's something that we had to consider as part of our evaluation. So we also considered whether we should consolidate and upgrade into one centralized communal system for all of the units. So that would be a significantly reduced number of systems in total. So that's going to provide some efficiencies for the owners in terms of ongoing system maintenance and costs over the life of the system. But it would require the installation of sewers and force mains for a collection system, which that would be fairly disruptive to the existing community there. There was also limited space for one single large system to accommodate all of the daily flow. So we also looked at whether we could do more than one system. So we looked at clustering them to service groups of houses. The initial servicing strategy that was selected with the owner was to maintain the current model of individual and shared systems and avoid the need for the installation of any collection and conveyance infrastructure, and also to avoid disrupting any of their open green spaces on the property to accommodate one communal system. So we worked with the MECP to obtain an ECA for this model, this servicing strategy. And as part of that, we came up with a risk assessment of the existing system. So that allowed us to prioritize which ones were the most vulnerable and needed to be addressed first, and which ones could be phased in. So we came up with a 5-year plan that was a part of the ECA that would allow us to phase the construction over a longer time period. And this just allows the owner to budget and plan their capital expenditure over a longer period of time. So 2 of the systems were prioritized to address the most vulnerable of the existing systems. And during this time when these were being implemented, the owners had some changes at their end. They had some different personnel came onto the team, and they requested that we just circle back and revisit the idea of a communal system, or at least a cluster, a couple of clusters, just to reduce the total number of systems on the property. So we reviewed the options again. There was one communal system already existing on the site for about 27 units, and we looked at expanding it, but there just wasn't quite enough space there to accommodate a system that would be large enough for everything, for all of the units remaining. And there really wasn't another space on the site that provided one area large enough for a single communal system. So then we looked at splitting it into more than one system. So we looked at clusters where we focused on a group of houses in close proximity and looked at servicing them with a system in proximity to the units, so that would minimize the amount of collection and conveyance piping over the site. And that would just allow us to split the flow into manageable sizes so that we could work with the space that we had available, since we didn't have room for one big system. So there were these 2 systems already in progress for 5 and 6 of the units. And so we'll call those System 1 and System 2. And then we designed 2 more systems. So one would take a group of 28 homes and another would do 68 homes. So each system is a treatment unit, a water loop biofilter, and we have a type A dispersal bed for each of these. So we went back to the ministry, we amended the ECA, and we worked with them to maintain that phased construction plan for implementation. So the ECA was set up to allow the client to implement these upgrades over several years, and that would give them time to budget and plan their capital expenditures. So this slide just gives you a bit of a feel for the size and the layout of the property that we were dealing with. And you can see how the groups of houses were kind of spread out. And we have the 2 ponds in the property in the center there that we were working with. So you can see here I've identified systems 1, 2, 3, and 4 and the different sizes associated with each one. In this photo you can see one of the smaller systems that was put in at first. So you can see we had the network of tanks that provided the treatment, and then we had an in-ground type A dispersal bed going in there. So we were able to fit this in space that we had available to us, and it was servicing 5 or 6 houses. So relatively small, but we were working with the space that we had. This is system 3, so it's for 28 units, so kind of the middle size of system on this property. And you can see here we had to use dewatering for any of the excavations because of the water table conditions on this property. We had to have dewatering of the excavation to be able to manage that. And we also selected the fiberglass tanks, and that was partly due to minimize the chance for infiltration, just because, you know, there's no joints in the tank. Everything is a little more watertight, so we selected that. You can see here we didn't always have the best working conditions just based on the time of year. We were installing some of these in the winter, but we had to get them in the ground and meet the timelines associated with the ECA that the ministry was expecting. So we definitely had to work around some not so great working conditions, but at the end of the day, we got everything installed and up and running. In these photos, you can just see some of the collection system. We did serviced as many of the units as we could with gravity sewer, and in a few places we had to install pumping stations to convey the sewage the rest of the way to the treatment system. So you can see here one of those pumping station units being installed. And with the water table conditions on the site, we actually had to have concrete anchor slabs for all of the tanks for buoyancy protection. And you can see here, this is the largest of the systems. So it's for 68 units and had a rated capacity of about 70,000 liters a day. So you can see here they were just pouring the concrete slab in the top photo there, the hold down slab, and then we got the large tanks in place, and then those were strapped down to the anchor points on the slab to make sure that we had adequate buoyancy protection. And this, you can see one of the larger dispersal beds being installed in progress there, and just the bottom photo there is when it was finished. We have our little control building, and we ended up fencing around the tank areas just for safety and to keep anyone from tampering with the system. So that was the finished product there. So in summary, this was a multi-year process for this project, and it's still not quite complete, but we're nearly there. So we started this work in 2012. It was a long process to look at the options and satisfy the ministry's requirements, get the necessary approvals, and then phase the construction in a way that was manageable for the owners to implement. And because it was an existing retrofit, it's always more challenging to find a solution. You've already got the homes there, people are living in them, you're working around site constraints and trying to service units that are lived in. You're working on a live system in some cases, so there's always more challenges trying to retrofit around existing conditions. And in this case, we had a number of site challenges that we had to overcome, with the conditions, the water table, but luckily we had good soils working in our favor, so that was one of the good things. We did have some approvals challenges. We did have to go through some significant efforts to satisfy the ministry and get the ECA approved. We certainly were not able to secure the MRA with the township, so we had to apply the financial assurance in its place. But at the end of the day, we came up with a successful solution that was feasible for the owner. It was approvable by the ministry, and it was affordable for the client because of the way we were able to stage the construction over a 5-year period and make it more manageable for them in that way. If you have questions about my presentation, please join the live Q&A session March 30th between 12 and 12:30, and I'd be happy to answer your questions. Thank you.